Good morning. Today we're going to talk about stick welding, safety, and setup. So the first thing we're going to talk about is safety. Like with anything out in the shop, you need to be wearing your safety glasses at all times. I want you guys wearing them under the helmets. Sometimes you'll be flipping your helmet up. Someone next to you might be chipping some slag. You don't want to get that in your eyes. The next thing is a weld helmet. A lot of people will say shade 10 is the required shade. On all these auto darkening helmets, you can adjust the shade. As long as you have a helmet on, it will protect you from getting arc eye. So I'll usually run like a 9 or 10, depending on how my eyes are looking, or maybe the arc's a little bright or the arc's a little dim. I'll adjust it. You'll notice if your eyes feel strained and you can't really see the puddle, you're too dark. If they feel strained and it's really bright, it's too light. So darken it up just a little bit. And kind of adjust it to your preference, but like anywhere between 9 and 11 will work really well. So next thing I recommend, not required, but earplugs. There are going to be sparks, especially when you start doing vertical and overhead. You're going to have sparks coming down on you. Don't want to get those in your ears. That's kind of a different type of pain that you don't want to feel. Along with the earplugs, a welder's cap or a baseball cap turned backwards works pretty well for keeping the sparks off your head. Another required piece of equipment, some welding gloves. And when you go out to buy your welding gloves, you can see these are pretty heavy, thick gloves. They've got what's called a gauntlet on it. It's this piece right here. You need to have a gauntlet on your gloves, and they do have to be leather. Like a mechanic's gloves, gardening gloves, something like that won't work. Generally, those are made out of a synthetic material, and if that catches on fire, that'll melt to your hands. We don't want that to happen. The last thing, this isn't a required piece of equipment, but I highly recommend it for a lot of things out in the metal shop, is a respirator, an N95 respirator. That just helps with all the smoke that doesn't go up into the ventilation system. It just makes it so you're not breathing that in. That's got a lot of heavy metals and stuff in it that you don't want to consume. Along with that, you can see I'm wearing a welding jacket. Just something to cover your arms. Has to be a natural fiber, so cotton, denim, wool, anything natural along the lines of that. Can't be synthetic, so your dry fits and stuff like that are all synthetic. Those will melt if they catch a spark. Long pants, you have to wear long pants for the same reason. You're going to have a lot of sparks coming on towards you, and you don't want to burn yourself. So shorts aren't allowed. And then also closed-toed shoes. You're going to have sparks falling on the ground towards your feet. You want to wear closed-toed shoes, and I would also recommend a leather shoe, just so it doesn't melt. So that's the safety. The next thing we're going to cover is rods. So I have a couple different rods here to show you. And as you'll notice, they all have a different number on them. So this one's a 6011. It might have been backwards for you. There we go, 6011. I've got a 6013 and a 7018. Those are kind of the three common rods that are used. So those all have different numbers on them. They all mean different things. So like if we look at a, well, we'll start with the 6011 because that was what I showed you. So we have a 6011. The first two numbers on there, so the 60 means that it has 60,000 pounds tensile strength. So if you're to make a weld with this and then pull on it, in theory, it should, if it's a perfect weld, it should hold 60,000 pounds before it breaks. And the next number on there is a 1. So that tells you that's an all-position rod. If that were a 2, it would be a flat and horizontal only. And if it were a 3, it would be a flat only rod. So And then the last number on there is also 1, and that tells you basically the flux properties on the rod. So a 6011, that last 1 tells you that it's a strong dig rod. So as you light up an arc, start welding with it, it's going to have a pretty violent arc, and it's going to dig really hard. So if you're trying to get through paint, rust, stuff like that, the 6011 will kind of bite and dig through that. We'll go over that one more time with you. So we have a different rod now. This is a 6013. The first 3 numbers are the same, so it has 60,000 pounds tensile strength. It's an all-position rod. The 6013 can be used for vertical up or down, which a lot of rods can't be welded vertical down. 6011 can also be welded vertical down. And then the 3 is the flux content, and a 3 is a really smooth running arc. And I'm not going to go through 7018 with you. The only thing that's different on a 7018 is the tensile strength. Going to hold 10,000 more pounds. But 7018s are very, very super common rod used out in industry. Really smooth running, strong rod. But what I'm going to show you on the 7018 is, let me put that right there and get those all aligned, is if you look at the wire on these, you see how those are 3 different sizes, 3 different diameters. These are probably the 3 most common rod diameters. So we have a 3/32, which is fairly common, used on thinner material. The next one over is an 1/8 inch. So that guy right here is an 1/8 inch. Really common. That's 90% of what's used in industry. And then the next one is what's called a 5/32. So I'll put those all next to each other so you can see them. 5/32, this one is. So that's used more for filling really fast. If you have a big gap you need to fill, you want to lay down a lot of material really quick, you're going to hop up to a 5/32 rod. You have to crank your amperage up and lay that on. And with that same thought, a 3/32 rod will run at a much lower amperage. It's going to take a lot less heat to heat up that thin wire than it will to heat up a 5/32 rod. So keep that in mind when you're selecting your amperage. The next thing we're going to discuss is welder polarity, because these welders can be ran on electrode positive or electrode negative. And I'll also explain AC, because some of our machines can be ran on AC, like our TIG welders. Also, some stick welders can be ran on AC. So the first thing we're going to cover is DC electrode negative. DC, and you'll see it abbreviated like this, DCEN. And where this is used is in TIG welding mostly. So I'll draw a tungsten here. Okay. An NDC electrode negative, that means your electrode. So when you're TIG welding, your tungsten's the electrode. This is going to be negatively charged. And then the plate you have down here will have a positive charge to it. Okay, so what that tells you is the electricity is going to flow from the negative to the positive. Okay, and in DC electrode negative welding, about 1/3 of your heat will be on the electrode, and 2/3 of the heat will be on the plate. Next, we'll go on to DCEP. Same thing, DC electrode positive. Where this is used most is stick welding, so I'll go ahead and draw a stick electrode. Oh, that's a big stick electrode. So your plate's negative now. Your rod is positive. And the heat distribution just flips on this. So 2/3 of the heat's on the rod, 1/3 of the heat is on the plate, which is good. That's what we want. Because when we're stick welding, we want this electrode to get kind of eaten away and deposit the material on the plate, which when we have 2/3 of the heat on the stick, it's going to. So this is used for a stick. And also we use this on MIG. So rather than this being the stick electrode, that could be the wire on a MIG welder. Okay, and then the last one that I want to discuss is AC. Some of you guys might know this stands for alternating current. So the current's going to alternate between positive and negative. And where we would use this is TIG welding on aluminum. So I'm going to draw a TIG electrode on aluminum. It's going to have a ball to end on it like that. I didn't draw my arrows over here. It's going to flow that way, flow that way. And then on AC, your electricity will flow this way, and then it'll switch. It'll flow that way. Some of you guys might have heard of like our electricity being 60 hertz. So that means that it's going to flip back and forth 60 times a second. So what that does is it puts half of our heat on the tungsten and half of the heat on the plate, which breaks up that oxide layer on the top of aluminum. So it really helps if you wire brush with a stainless steel wire brush first, but you're not always going to get all the oxide layer off. So you will have some oxide layer on aluminum that you'll have to use the cleaning motion of AC to get off for you. So now we'll go ahead and go out in the shop. I will set up the stick welder. I'll show you what it looks like to be on DCEP, show you what it looks like to be on DCEN, and go from there. One thing I forgot to mention, we're right here by the entrance to the welding shop. We have our ventilation fans. So before you start welding, don't forget to turn on the arc welder exhaust fan. Flip that switch on, and that will turn on the ventilation for all the stick welders. So here we are out in the shop, looking at the front of this machine. The first thing I am going to do is flip this front panel down. And there's a bunch of different settings on here. And I want to flip this to stick. So if it's not already adjusted over to stick, go ahead and turn that knob, get it adjusted to stick. And for 6013, I turn this left knob right here is arc control. Turn that arc control down to 0 for 6013. For 7018, I usually turn it up to about 50. And there's a little white knob on there. You'll see it. And then on the right side here, there's a knob that can switch between panel and remote. Make sure that's set to panel. Now that all those are set, I'm going to go ahead and shut that, turn my machine on. and your digital readout will pop out on the front. For 1/8, 6010, or 6011, and 1/8, 6013, 100 amps would be a good starting spot. For 1/8, 7018, you can turn that up to about 125. So, and to adjust that, that's this knob on the right side here. So that's getting your amperage set. As far as machine polarity, DCE and DCEP, that's a matter of these two plugs on the front of the machine right here. If you twist those, they'll come out. They have a little keyway on them right here. So you have to get that aligned on there. So twist them. If you go too far, just twist it back the other way. And on here, one of these is going to say G for ground, and the other one will say E for electrode holder. Okay, so we're going to be welding electrode positive, so we're going to put the E in the positive. And this is really important. After you put this in, you need to twist that and get it tight. If it's not tight, it'll have bad connection, and you'll run into issues. The same on the ground. Get that nice and tight. So the machine's set up. The one other thing, if your machine won't turn on, up on the wall right here, we have a breaker. Make sure that breaker is in the on position. Okay, now we're looking at our welding table. And we have our electrode holder and our ground clamp right here. Your ground clamp needs to be attached as close as you can to your material. So if you're welding on something on this table, just clamping it on the back side of the table right there will be fine. But if you're working up here, maybe you're doing some vertical or overhead, you need to move that clamp up like that. Because if you don't, it's got to flow, the electricity has to flow all the way up here and then out, and that will cause you some issues. Also, it really helps on here. You can see how this is shiny bright metal versus having like a mill scale on it. It really helps to bare your material so it can make good contact. So that's the ground clamp. And we'll go ahead and take a look at the electrode holder. I'm not sure if you guys are going to be able to see this on the camera or not. Probably not very well. But on the inside of this electrode holder, if I just push down on this, that'll open the clamp up. There's going to be a couple different ways I can put my electrode in there. So I can put it in straight. A little bit further down, there's an angled down groove. There's an angled up groove. And then at the very bottom, there's another straight groove. And also, most of these will have a groove, so you can put it in straight like that. When you place your electrode in the electrode holder, don't just randomly throw it in there and hope that it's going to fall in one of these grooves, because you see how floppy that is? That's the last thing you want as you're welding. So find a groove, stick it in there. Like with this in the straight groove, you see how rigid that is? That's what you want. And when I clamp this on here, I'm clamping it on the bare part of the end of the rod. Just like that. And what I recommend, what I am most comfortable with, is the angled down position. For the simple reason, when I'm welding, I can set my elbows on my knees, make a couple points of contact, and then I'm really super steady. The last thing we have to talk about is the ventilation. I like to keep my vent hood nice and close. As you can see here, this is below the level of my head, in hopes that this will suck out any fumes before they get up to my head. Sometimes I'll see students at these way up high, and I think that makes it pointless. You're breathing in all the fumes before they get sucked up. And the whole point of having this ventilation is to protect you as a welder. So keep it nice and low. Make sure you can still be comfortable working with it, though. Um, you can put it on the back side of the table. They're adjustable, so you can kind of move them wherever works for you. Now with my machine off, I'm going to go ahead and put this electrode in the downward position and show you guys kind of how to start an arc on here. And I'm going to also move you in. Now I'll go ahead and show you guys how to start an arc. So I have my piece of metal I'm going to be welding on. As you can see, it's nice and shiny bright. I took it over to the belt sander, polished it up, got all that mill scale off of it. Now with the machine off, I'm going to go ahead and put my electrode in the electrode holder, angled down like I was saying. And keep in mind, if you do have the machine on, as soon as you touch the end of the rod to the plate, you're going to have electricity flowing. So I would recommend doing this with the machine off a couple times. So all that you're going to do is get your rod close to the plate, and you're just going to do kind of a real light flick motion. Let me see if I can get a better view of that right here. You're just going to bring it down and real lightly touch it just like that. Some people think that it works better if you kind of come down and peck at it. I usually find that it sticks, so I kind of strike just like I'm striking a match. And then what you'll find is every once in a while, especially when you're starting out, your electrode will stick and you won't be able to get it off. What you can usually do is just wiggle it back and forth and it'll pop off. If it doesn't pop off within the first 2 seconds, you need to reach back and shut your machine off. And then you can take your electrode holder off of the rod, let the rod cool down for a couple seconds, and then just bend the rod back and forth and it'll break off. Then one other trick, and this works really well for 7018, is when you start welding with your 7018, it's going to look something like this. There's the camera right here. It'll look something like that. It'll kind of have a little ball of slag at the end of it. Whereas a brand new rod, you can see how the wire's kind of exposed right here, just a little bit, and it's not on this. If you take these over to the belt sander after you've welded with them for a little bit and you broke the arc off, take them over to the belt sander and just really quickly sand them straight on and then tip it to about a 10-degree angle and just real quick rotate them around. That will add a brand new end to it. I just ran over to the belt sander real quick and hit that same rod. And now you can see it's nice bright metal at the end. And that rod's going to start a lot easier than it would if it had that ball of slag at the end of it. Now once you get your arc started and initiated, you're going to hold the rod the same diameter as whatever the wire is. So an 1/8 inch rod, you're going to hold about an 1/8 of an inch. And you might feel the flux on the outside of the rod here drag on your plate a little bit. That's okay. So about an 1/8 of an inch. And I'm also going to be about a 30-degree to 45-degree angle somewhere in here. and I'm going to move straight, coming to the right. And if you're left-handed, it'll be just the opposite. So about 30 to 45 degrees, 20, 45 degrees, somewhere in there. And you're going to move straight to the left, as straight as you can. And what I find sometimes helps me is I'll draw some soapstone lines on here for myself to follow. Just something that I can see as I'm going along. It shouldn't take any side-to-side motion on a 60-13 or a 70-18. With a 60-11, what we do is called a whip and pause. So that's a little bit more of an advanced motion. I'll zoom in closer and show you again. So the whip and pause, what that's going to look like is you're going to get your rod started. You're going to whip forward a little bit, and then you'll come back. And when I go forward, I kind of drag the rod a little bit. When I come back, I lift it up a little bit. And these are fairly small motions. I'd say about a 1/4 inch forward, 1/8 inch back, 1/4 inch forward, 1/8 inch back. You're just kind of working it back and forth. And the reason you whip out of the puddle is to let the puddle cool down, and then you come back to add some more material. You whip out, let the puddle cool down, come back. And that technique is used on open root butt welds, like for pipe, where you have an open root. You have to let that puddle cool down, or you're just going to blow through it. Also, one last thing I wanted to add in, as you're welding, because you're not just going to be welding here at the shop. Always look around yourself, inspect what's around you. If you're welding in your garage, you don't want any flammable materials. I know the TIG welding booths here have students clean material with acetone. That acetone needs to be removed out of the booth because that is a flammable material. And also, while you're chipping slag, keep your helmet down. That slag's going to be just as hot as the weld underneath it. And if you're chipping that and that gets on your face, you don't want that. So keep your helmet down. That'll protect your face from any hot slag that become flying off. And also keep in mind, this material you're just welding on is extremely hot. You just created molten metal and fused your weld material to the plate. So don't grab that with your hand. It's extremely hot. Use a pair of pliers and then go take it over to the cooling bin and dunk it in the cooling bin. As far as along with cooling goes, if you're doing anything critical, say you're doing a bend test, you do not want to dunk that material in the cooling bin, because what that'll do is that'll cause your weld to get brittle. Cooling it rapidly will. So generally, if you're preparing for a bend test, you weld out your plate. You're only going to let it cool down when it's all done. And I just let it naturally cool down. Set it somewhere right hot on it and just let it cool down for a day.